Hey Jill, welcome to Airhex FM.
Um, Thanks for having me.
Yeah, let's see. What was your first computer?
Oh, my first computer. Um, My first computer that I myself had was actually a Z80 running CPM with a connected terminal. Uh, but probably the first computer I used was a VAX 11780.
Okay.
It wasn't mine though.
So you look young. So I thought, your first computer is like the Vega, Azul Vega. This will be the right answer, right? So,
Yeah,
you,
as a teenager, I went straight into hardware design, and before I had any computers, I designed my own. Yeah, no.
okay. So and you wish that, or why you wanted a computer back then?
um, so I grew up um, thinking that I would never want to play with a computer or touch a computer because people wanting me to, and as a teenager, you resist what people want you to do. My brother was into computers. My dad was into computers. They had computers lying around, but I wouldn't touch any of that stuff. I think that at the time, my father was teaching at Harvey Mudd College as a visiting professor, and I would hang around their computer center because they had computer games.
Hmm.
Um, and so I played adventure and Star Trek games on a VAX
Hmm.
on
Oh,
a terminal, an 84 by
yeah.
20, an 80 by 24 character terminal with text stuff, right?
Hmm.
So I would just play, and then I remember very specifically that there was something with an adventure game where you get stuck somewhere, and there was only one way to get out of there, and everybody knew it, but I didn't, and I didn't want to learn it for somebody else. So I basically ended up learning a lot about how to break into and disassemble code just so I could find XYZZY as the secret thing you have to say to move to the next step in the computer game.
Aha.
Um, that's the motivation. I was 14, so
And you managed to do that?
yeah, yeah. It was like, okay, there's a reason to do all this, so yeah. Then everything comes up. But
Yeah, but how long it
I was
took,
very resistant to learning any of that stuff.
And how long did it took? So how long it took, to do that? No, it was like weeks.
I don't remember, but it was one of those, was a very long game. You play over many sessions, and then you get stuck somewhere, and you have so much invested in having
Hmm.
gotten there that I remember this was probably a couple of weeks at least of figuring it out. Um,
Yeah, it was
and
a good designed game, right? So this is how the next programmer happened, right?
I guess so.
It was sponsored by a software company, I think.
Yeah.
Exactly this. The
I mean,
okay.
this is 1981, probably.
Wow.
So at the time, I don't think people that built games thought of how to obfuscate what's in memory, so you can't scan the strings and find it. It's like, to me, it was mostly okay. How do I find out what this program might want me to say?
Hmm. But
Well,
was it
let's look
were,
up
were
the
they
things, right? You know,
were they commercial games on the VAX? No, this was just like
no, nothing was commercial. The
yeah.
computer belonged to a university.
Hmm.
You happened to be able to use it. The games were just games that were there, and
Hmm.
people would play them
Exactly.
instead of doing work. I was a teenager, so I didn't have to do any work, so I was just playing them.
Hmm.
Um, but fundamentally, it's learning that you could scan binaries for strings to see
Hmm.
if any of them are interesting things you could say to get out of a spot in adventure. That's my foray into programming.
And the Z80 you got, you wanted to play, or already were interested in programming?
No, at that point, I got more interested in programming. I think my first language was Pascal.
Okay.
Um,
Not
and
basic.
no, not basic. Interesting.
Interesting.
Yeah. Again, it started on a VAX.
Ah, okay.
So uh, it had basic was actually a weird language for VAX.
Yeah. Yeah.
Um, and then like the Z80 and stuff was I started doing home computer things. I started actually off with a terminal and a 300 baud modem
Mm-hmm.
talking to a VAX. Um, and then getting a computer in my own house, that was okay, what can I do? And it was like early like S100 boards and an S100 bus to plug them into, and I played a lot with soldering irons and blew up a bunch of capacitors before I got things right. You know, actually
Mm-hmm.
put together computer stuff.
Yeah. And
Back
what is
then.
your motivation? What do you wanted to achieve? You know.
So I think some of it was curiosity and playing around. Some of it was um, I actually worked at a very young age and made good money doing computer stuff. Not sure at what point exactly, and it went from playing around to making money with it. But I had the good fortune of um, my father had a consulting business
Mm-hmm.
for civil engineering stuff and 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 doing all kinds of CAD and finite element analysis was just stuff people
Mm-hmm.
needed and did. And at the time, you rented computer time to do those things.
Mm-hmm.
So being able to put it together a computer, we could do it in our house instead, and still, you because this was all stuff people needed. You
Mm-hmm.
could find things you could do with computers that people would pay for. And I remember the computers were making more than I did per hour.
Mm-hmm.
Um, so as a teenager, I actually learned how to put together microvaxes and fax VMS workstations out of spare parts and or other things to put more computer together. And I think I had 4 computers working for me at some point. When I say working for me, I mean they were making money by the hour doing things people paid for. Um,
Uh-huh. So you
so
were the scheduler, right? So this was your.
yeah, yeah. Like, a 17-year-old, how much do you pay them for doing work? But a computer, you pay $25 an hour to.
Mm-hmm.
Um, so, that very different than what we have these days. So it was always, and I got to play a lot with the cool toys and learn a lot about them. And I was a Vax VMS sysadmin for a while. And
Was there
all,
like calculations ran on your machines? I guess so, right? Some, yeah. Was it?
um,
Mm-hmm.
yeah, it was the two big things were finite element analysis applications like ANSYS
Mm-hmm.
and CAD software, mechanical CAD
Mm-hmm.
software
Mm-hmm.
that was taking off in the early '80s, and I
Mm-hmm.
played around a lot with those things too.
But you run just the software, run the software. It's not like you wrote the software, right?
Well, you would run the software, but you would do things with it. So you'd have utilities and munch things and transform things.
Mm-hmm.
So you'd program.
Mm-hmm.
And yeah, at some point I needed to do some image analysis, so I wrote my own code for that. You end up just coding.
Mm-hmm.
Um,
Okay.
and like I said, it was probably Pascal and to some degree Basic once I started playing with other things.
Okay.
Um, and then went on to C. C was I remember Unix was this weird thing back then.
Okay.
Weird thing coming from universities and stuff. And C really came with Unix.
Mm-hmm.
It wasn't really around much before.
And why you stopped using the Vaxis or VMS? I think was the OS, right, back then.
So I used Vaxes probably until the mid '80s,
Mm-hmm.
um, and then like home computers, I had an Apple,
Mm-hmm.
an Apple II
Mm-hmm.
that I bought with my own well-earned money. Um, and that was mostly for playing around.
Mm-hmm.
I'd play games, I'd hack on games. There was this whole cool. At the time, there were you would buy a game on a floppy disk,
Mm-hmm.
and there was this whole thing about how to crack the game so you can copy the game, and the people who write the games would do all kinds of things to prevent the game from working unless it was their floppy disk. So there's all this reverse engineering of figuring out exactly where the program figures out if it's the disk and hacking the program so it thinks it's the disk. You end up with a lot of, playing around with other teenagers doing that. And it was more the challenge of doing stuff like that. So hacking.
And learning.
Yeah, a lot of learning from there. Basic 6502 assembly, machine code. Because if you're going to disassemble, you're going to reverse engineer stuff, you actually start from the machine code and disassemble it, right?
You were 18, I suppose, right? 18, 19?
That was probably 16, 17, stuff like that, yeah. But yeah, I guess that cracking the game motivation was my early foray into computing, and that starts by reading the binaries.
Okay.
So you end up, after you figure out the strings, you want to understand the instructions, so you figure out what the actual machine code does, and then you, like, to me, learning assembly was after learning how to read machine code. It was backward. But yeah, just I'd always played with those things and always found somehow ways where I was making good money as a teenager, a lot more than I could dream of, doing any of these things. So,
and were you wise with the money, or you spend, everything on, I don't know?
So to this day, I have this. The one thing I'm unwise with, but I actually think very wise with in practice, is I spend money on computers. I'm not sure why, but it comes back.
Yeah.
I'll buy nice things when they're computer things. But, I bought a camera or something with money I did. But see, I'll spend money on toys like this.
Yeah. I would like to spend money on toys like this, but they are not available still, in Germany.
Oh, right. Well, soon.
Yeah.
But yeah, and like an Apple Vision Pro, what is this thing good for? I don't know. But I'm pretty sure this is money well spent. Not because the device is worth it. It's because my playing around with it is worth it.
I'm absolute with you. So this was also my strategy. So I for instance, I created my own server in the early 2000s. But I said, okay, let's have some fun. So I bought, the best possible chassis, the best possible motherboard, and there was still peanuts. I remember, the most expensive server I could build from Amazon was like $3,000 basically, which is nothing. And this is crazy machine. I still have running one, right? So every 3 years I have fun. I just build, the most expensive machine to understand how fast it is, how it feels, and I learn a lot. And this is fun, The same, if I like a keyboard, I buy a keyboard because I'm working. And this is, I would say, a little motivation, right? So you have a new gear, you work with it, and if you use it professionally, so this is actually fun, and you learn a lot, right?
Yeah, exactly. It's to me, the waiting until the price comes down or it's the most cost effective. It means you're not on the cutting edge and you're not learning the latest stuff. So, look at the time. These days, I mean, yeah, these are expensive toys, but for people at our age, it's toys, right?
Yeah.
They're expensive, but they're still at the toy level. When I was younger, it was probably a bigger investment if you think about it. But for example, I bought my own Sun workstation for home in the late 80s because I wanted a computer that wasn't a PC.
I wanted to, but I couldn't. The cool story is I was actually a trainer for Sun Microsystems in Germany, a freelancer, but they couldn't sell it because they say they are just, how to call it, educational, Sun Educational Services, SES, and they were not allowed to sell me a machine. It's like, I would really like to have one. No, it's not possible. This was the already, had a chat here on the podcast about that. But I would buy it, and for the same reason, I wanted to try out Solaris. So I was and wanted to see how it feels, how it works, just for fun, and I would for sure learn something. It's not like it is for nothing.
And I somehow always found something to do with those computers I spent money. It's like for me, I was in Israel at the time, and similarly, I think I couldn't buy it from the local Sun representative, so I figured out how to buy it in the U.S. and bring it over. They had Sun, but they couldn't sell it to individuals for whatever reason. And I played around with it, but then I ended up literally getting hired to do at the time there was SunView,
Hmm.
the library before OpenView. So to do the bidirectional text,
Wow.
Hebrew and Arabic are right to left rather than left to right languages.
You were hired by Sun?
By the company that was representing Sun in
Yeah.
Israel because they
Hmm.
needed it for business, right?
Yeah.
So I ended up retooling the SunView thing to
Cool.
be bidirectional, and then that ended up being somehow ended up at Sun because they used it outside of Israel for all those other countries that also right to left.
Okay.
But yeah, and I don't, I had the Sun workstation as my own computer. I could do this thing. Somebody wanted it. It easily paid for the workstation, right?
Yeah.
Um,
Hmm. And how
so
old were you? Still 17? No, older, I guess, right?
no, this was in my early 20s.
Okay.
Yeah.
So you became a software engineer back then?
Well, I'm an electrical engineer in training, so I went.
Okay.
Um, I studied electrical engineering and
Hmm.
then, but always worked in software. I've always tinkered with hardware since I was a
Hmm.
teenager. But it's always been the software that I build on that stuff that I really did.
Hmm. So what happened then? So you get your first Sun machine. So I'm curious what happens then, because so
Um,
or what was your
this
job? You
is,
you you, you were a like mechanical engineer or hardware engineer, and you worked for fun with software, or what was the story back then?
well, I actually worked for I worked through school doing all kinds of software and CAD and that stuff I was talking about, where
Hmm.
CAD and finite element and that kind of stuff, doing stuff that people needed for building things. Um, I spent 5 years in the Israeli Navy as a software engineer
Okay.
after I graduated in electrical engineering.
You learned a lot there.
I did. I did. I mean, you always look. I think in our profession we never stop learning.
Yeah.
So I definitely learned a lot. Did a lot of fun things and things. You get to play with things that would have no reason to play with
Hmm.
in other environments. Um, and then I also ended up because like I had quirks. Like for example, I really liked the email and the Usenet that we had in university,
Hmm.
um, but it was only available when you were in the university,
Hmm.
right? Um, and then they had very limited amounts of modem access in.
Hmm.
So I could get a modem at home or connect a computer as a modem and log in just to read my email, but you would literally have to dial in just to and get and log in just to be able to see email. And I'm very spoiled. I'm lazy and spoiled. So I wanted something where the email gets to my desk
Hmm.
and that I and where Usenet is on my desk.
Hmm.
So I got my Sun workstation and try to connect it. And it turned out at the time that outside of educational and company organizations, there was no connection to this is the internet or pre-internet. It was the net. Usenet was a store and forward network. It
Hmm.
wasn't IP where you connect anything to anything. But we had email and we had news and Usenet that worked
Hmm.
like they do today with say Google groups. Um, and I wanted to connect to this thing so I could do the same
Hmm.
things I could do in the university. Um, and I had this romantic notion that there's probably other people crazy like me around, and maybe together we can connect a small network and
Hmm.
do overseas calls to other places so we could connect. But I only found one other crazy guy to do it with me, and we started connecting to UUNet in the US using
Hmm.
UCP with overseas calls.
Hmm.
But the idea was I need other people like me to share the expenses of these very expensive phone calls with. Couldn't find them. But I did start finding all kinds of tech companies that had this problem where they were small. They weren't IBM or Intel, and they weren't an educational institution. So they had no connectivity. And they had like CompuServe or other things that they could get some things with, but they wanted the same things, email and Usenet, for work. Um, and I happened to actually have one connected. So a small company here and there started connecting to my bedroom to get Usenet and email. And fast forward a couple years forward, and I had like 20 or 30 high-tech startups in Israel running their Usenet traffic through my bedroom. I was basically an ISP.
Mhm. It was a hot bedroom, right? Then, so
At the peak, I had 6 modems there.
yeah.
But and then then the real internet happened with IP, and I kind of handed all this over to somebody else. And I wasn't trying to make a profit. I was trying to get email and Usenet on my desk and share expenses. But it ended up paying for a lot of computers and printers and modems and stuff like that.
Yeah, and you learned a lot and had fun, right? At least nice memories right now.
Oh yeah, definitely a lot of interesting memories from there.
Yeah,
I met a lot of people in the industry through that.
Yeah, but how you found the companies? I mean, so you had to be a little bit businessman, otherwise it wouldn't work, right? I mean,
so it's not like I went out and advertised and marketed. I was looking for people who need this. It mostly through university stuff and friends, and then people end up at companies and say, we also don't have what we used to have at the Technion. And I say, well, I hooked it up and say, wait, maybe we can too. And then the first few companies, it was friends that worked there that realized that they could use it. And then from there, it's word of mouth mostly. People came and asked. Like at some point, this was like I kept trying to figure out I didn't sign up to doing this. This is like you wake up one day and you're running an ISP and you realize that if something goes wrong in your house, half the tech companies in Israel lose email connectivity, and this was not the plan. This was so I could have email. So I did find somebody to hand it all to so that they could be responsible with it.
Okay. So what was the next story then? It becomes more and more interesting,
Oh,
so you were already serverless in the early days, So you were paid by minute with the software. Then it became, ASP, and now I'm curious what happens now.
Well, I moved to the U.S. and to the Silicon Valley in 1994.
Why?
Well, I always planned to move. I always knew I would probably move to the U.S. and work for a few years at least. I'm a U.S. citizen. I was born in Boston, so I didn't have any immigration, which is with doing it. Just grew up in Israel. And I do remember, interestingly, there's a point in time I remember when I knew I was going to live in Silicon Valley. I was visiting a good friend in Santa Cruz University. He was still in school back then in '91. I had done this project on the SunView stuff I talked about, and they wanted. I was visiting the U.S. and they wanted me to visit Sun here because to work through handing the software to them and stuff. So I was actually in Santa Cruz and I was driving to Mountain View. For those of you who are, who don't visit Silicon Valley a lot, Santa Cruz is actually on the other side of the mountains from the main part of Silicon Valley.
Okay.
And I was driving to the Sun campus on Highway 101. And I remember seeing a big billboard on the right side at where today I know that's the Intel headquarters, but was a big billboard, and it said Intel 35 nanosecond static cache RAM and a picture of a chip on it. I mean, you see, I remember it to this day.
A good billboard, right? So this was
a good billboard. And I'm driving by this, past the thing, it's past me, and I'm thinking to myself, this is cool. I know what this is. I understand the billboard. But then it was literally somebody slapped me. It was a wake-up moment. It's wait a minute. I just passed a billboard on a freeway that's advertising static cache RAM chips. Who's driving on this freeway? And realizing it's I understand what this is, but nobody normally I know does. And realizing that this is a place where people will actually spend money on a billboard to the people driving on the freeway for this stuff. This is where my people live.
Okay.
It's like there are people like me here,
Yeah.
and it was just this realization that it's kind of the center of the universe for that kind of stuff, at least then.
Hmm.
Um, and it hasn't dramatically changed since. So I moved here a couple years later and did a bunch of independent consulting and contracting work, building products for people at a time when
In which languages? Which languages you pick or technologies may be interesting to know. So what's.
um, it was a lot of C, C++.
Hmm.
Um, in the mid 90s, yeah, that was pretty much the languages
Hmm.
themselves. The operating systems were mostly Unix
Hmm.
variations at the time: Sun OS,
Hmm.
Solaris, and IX and HPUX, and those things. And the kind of projects were kind of cool. Everything from all kinds of cool integrated systems with device drivers for GPSs and antennas
Hmm.
to to printer and imaging system device drivers. I ended up doing a lot of device drivers and operating systems,
Hmm. Okay.
and then firewalls and network equipment and all kinds of stuff.
Hmm.
So it was a fun time when you could do very well doing contracting work, build a product, and then move on and build another product and build another product. You wouldn't work for the company long term.
Hmm.
Or some people didn't work for companies long term. You would basically build new things.
Hmm.
I did several of those. And that really changed when startups became a different thing in the late 90s and mid late 90s, where um, it went from making a lot of, making good money for building software to also having things like stock options and
Hmm.
equity. And the real compensation started coming from there. So you started getting offers you couldn't refuse for employment.
Hmm.
But I built a bunch of cool projects before that.
What were the coolest projects? So what was the coolest thing you built back then?
How do you pick? I would say one of the really cool ones is I worked with Stratus Computer
Hmm.
um, on fault tolerant computer systems,
Uh-huh.
and these were beautiful pieces of hardware where anything could break, including the CPU, and nothing would stop.
Okay.
So everything was fault tolerant. This is back when software was not fault tolerant, so the hardware needed to be.
Hmm.
Um, so your web server, the Netscape web server, or the mail server, or the file server, you didn't; those things could not go down,
Hmm.
but they ran on one computer.
Hmm.
Um, Stratus came from the mainframe world and built interesting fault-tolerant hardware for other purposes, and they had the hardware technology, but there was not a lot of software for their operating system. And they ran a project where they wanted to basically bring an operating system that had a lot of software on it
Hmm.
to their fault-tolerant hardware.
Hmm.
They picked HPUX because they built their hardware out of HPPA
Hmm.
RISC CPUs. So the project was basically get HPUX and fault-tolerant hardware, get it to work, and there was a lot of cool things under the hood. Like each CPU was actually 4 CPUs running in 2 pairs of lock steps that check each other,
Okay.
so that if anything breaks, the part that is wrong bows out. Beautiful pieces of hardware. But the interesting and most complicated part is when it's not in sync and it's still running, how do you bring it back to be in sync? So say
Always,
something broke and now
always the
you
challenge, right? Partial failure. This is always challenge, I would say. Split
so,
brain.
so
Yeah.
it's beautiful when it all works in sync, and if something breaks, nothing stops working. But then you have to replace the part that breaks, um, and still not interrupt anything running. So the hardware has all kinds of assists to that, but that's where there's a lot of software orchestration for doing all that.
And you managed to do this?
Yeah, there was pretty prescribed. Like the technology parts were all there. It was get HPUX to do it, and
Okay.
get that thing to run all the software HPUX can run. And at the end of it, we ended up with a working thing. And the cool demo was they had a small version of the machine that basically was like a big box with 2 huge suitcases
Hmm.
vertically going into it. Each suitcase had half the CPU and the memory in the machine, or half the
Hmm.
redundant thing. So you'd have this thing, it's all running, all the lights are green, and then you go and you just take out one of the suitcases. Like you flip a lever and you pull it out, and you're running a demo and it's not stopping, right?
Mhm.
It's like everything's still right. So cool. But then you put the suitcase back in, you put the lever back in, all kinds of nice lights go on the front, blinking all kinds of stuff until they go back to green. Nothing stopped, and then you take the other suitcase out. And throughout this whole thing, the software never stopped running.
Yeah.
So yeah, that was, I think, probably, as far as exotic, cool things, that's probably one of the cooler ones I've worked on.
Maybe it comes back, don't you think? Such a design, because no energy efficiency and now back to monolithic architectures in one point of time. Should swing back and say, okay, what if we build small machines which are very reliable and just one everything on it, and could happen, right, for special kind of software.
I doubt we'll ever go back there. I mean,
Okay.
It's very expensive to do, and it's
Mhm.
very challenging to do, and it's basically solving a problem that software has solved now in other ways. So if software can deal with the fact that a single instance goes away, then you don't need expensive hardware that doesn't break.
Yeah, but the ways, if you do a software, you need redundancy. So you're basically running on two machines at the same time. So of course, we have the load balancer, but there's a huge overhead. But if you manage, to do, I mean, and from the energy perspective, no one cares about performance. So if you're running in the cloud,
Yeah.
it's usually slower anyway, right? So I would say, but
So
from the
I think of it this way. Back then, a server,
Mhm.
we thought of them as big things, right?
Yeah.
100 or 200 or 300 megahertz chips.
Yeah.
Was a big thing with many megabytes of memory.
Yeah, sure.
Not gigabytes memory. It was like 64 megabytes.
Yeah. This was
that
big, 64 megabytes. My workstation at 64 was crazy. So I was proud of 32, and I remember the upgrade to 64 megs. So this was already a thing, right? Yeah.
So that was big. And then we would like the server vertically scaling was how big of a server can you
Yeah.
have that will do this stuff. But software ran on one thing.
Yeah.
And we've since then graduated to software can run and does run inherently on more than one thing. And most things that have any real footprint need a lot of computers. It's not how many things can you put in one computer. It's how many computers do you need to run that one thing. Google does not run on one laptop.
Yeah.
And not two either, right?
Mhm.
Now, yeah, here and there we run things that are cool, like anything in your house and anything embedded. Yeah, it's still running on one thing. But most software that has big impact on the world is running on many computers at the same time. So the scale kind of needs more than one computer anyway. More than what one computer could put together in one thing. Because you already have to deal with that, you also are forced to deal with the availability part. Now, the availability part is the really cool thing is once the software can handle pieces of it stopping the work, lateral load balancers, clusters, synchronized caches, whatever it is, but you can survive failure of one element, then the elements can be cheap. It's just like with RAID systems. RAID really comes out of, it's a bunch of really cheap disks that achieve redundancy rather than a disk that never failed. And it's much cheaper to build things that way. I think both hardware and software wise. Now, I had a lot of fun building systems that don't break. The actual criteria for shipping this project was to reach a 1-year MTBSI. MTBSI stands for a mean time between system interruption.
Okay.
And we need to statistically show it, and we had less than it. Like you can't measure it for a year because that's too low. So you have all kinds of valid statistical ways to project MTBSI from stress tests. But yeah, we had systems that would not go down for an entire year. And it turned out that a lot of the software needs to be built well enough to actually stay up for a year, regardless of how good the hardware is. A lot of software doesn't run for a year without breaking.
Was it Stratus computers, right?
Yeah, this was Stratus. But then at the time, for example, HPUX of the different Unixes was probably one of the most rock solid Unix implementations. I'm not sure Sun OS would have stayed up for a year.
What I remember back then, there was a Tandem, another computer, which also redundant, right? Was it somehow similar to? It was also an HP product, I think, right?
It was a partnership with HP.
Okay.
Tandem was independent, and I think was bought by HP at some point, or Compaq and then HP.
Yeah.
But that was Tandem and Stratus were the two companies making fault-tolerant hardware.
Okay.
They had different approaches. Tandem was sort of a 3 thing with a majority vote between them.
Wow,
quorum. There's 4 things where a pair and a pair and a pair checks itself, so it bows out if it's broken. So the hardware was very different in design. Some of the software layers were different too, but fundamentally, I'd say it was easier to get general software to run on Stratus than on Tandem. In Tandem, you had to program to the concept. And with Stratus, we're able to transparently run existing HPUX. Now, Oracle databases, Netscape servers, mail servers, they all just ran. Everything just worked. That was probably one of my early introductions to it. Just compatibility at the hard compatibility to just make software that runs with no change.
You mentioned the Netscape server several times. So interestingly, in one of my early projects, there was a company which run JavaScript on the backend on Netscape.
Yep,
and
that's where it came from, right?
Yeah, server-side JavaScript. It was, I think, 2001, I guess, something like this. And the problem is no one wanted to have JavaScript on the server. So what we did, we had to migrate from this to Java on the server. This was funny, because they say, okay, I don't know why they started with JavaScript, but over weeks, I helped them to migrate from JavaScript to Java. So this was one of my assignments now. And then 10 years later, Node happened. Exactly 10 years later, actually. So if they would survive, the 10 years, they would be in the next, hype cycle.
Yeah. Well, I mean, but JavaScript actually started on the server side with Netscape, right? It came from Netscape.
SuitSpot was the name, right, of the server. Netscape SuitSpot, I think.
I don't remember. Maybe, yeah.
Yeah.
SuitSpot, yeah, probably. But and I mean, I still find it funny that it's called JavaScript.
Yeah. But this was the deal, right, with between Sun and Netscape. So, Java is going to be distributed with applets, and then but Netscape wanted to have the cool thing called Java. So they wanted to sound the scripting language cool. So and they use Java for it. So no.
And there's some similarities in the syntax. Some small similarities in the syntax.
Yeah.
It's somewhat recognizable, but I mean, look, JavaScript. I don't think we know anybody who thinks JavaScript is a pretty language. I think it's an extremely successful one in spite of the language, not because of the language.
But what I always say, the longer we wait, the more JavaScript becomes like Java. No, we are not far. No, we have already almost packages called modules. So with JSDoc you get type safety, and what I think is really interesting. At the beginning, as JavaScript became a little bit more popular, everyone said, the type safety of Java is really bad. We cannot move forward. And this is really, the compiler is bad because we would like to be more productive. And JavaScript is great. And Ruby, by the way, as well, duck typing or whatever. We can just write code fast and we're really productive. And I always wondered, what happens afterwards? How the, refactoring, how the project are going to be maintainable. And now we see, JavaScript tries to be now type safe. So this is the interesting part.
There's a lot of great script out there for people who just...
And JavaScript itself, with JSDoc and now the new proposals are interesting, right?
Yep.
But,
in Java, we do have that little sin of erasure in generics, right? Which if we're still paying for. It's the example of what happens when you don't do actual strong typing.
Yeah.
And how badly you end up having to pay for it. But to me, it's always I'm actually I don't have a language religion.
But Jill, we cannot talk about Java because it didn't happen in your timeline yet. So what happened between Stratos and Java?
Well, the Stratus thing was probably about the same time.
Yeah.
So one of the other quirks I had, because I was buying my own Sun workstations for home, and I was already on my second or third generation of it. At the time, you had the workstation, and then there was all this software that you would want, Solaris and the compiler suite and all the tools and other things. And this was very expensive stuff, and this was just me on my own. And I found out early on that Sun had a developer conference that it ran once a year, so that's a Sun developer conference, Solaris developer conference. And if you attended the conference, you got this packet with CDs on it that had all the software. So for a developer, like you got basically license and the actual software. So you got the new and latest Solaris, you got the compilers, you got the tools. So I still lived in Israel at the time, but I would pay for friends of mine, those in Santa Cruz, to go and attend the Sun Developer Conference, have fun there, and just send me the CDs when they're done.
Oh, okay.
Because it was cheaper than buying the software, like 10 times cheaper than buying the software. So they would send me pictures of them jumping and getting stuck on Velcro walls, and along with the thing. So I would, when I moved here, I attended it, the Sun Developer Conference every year. It was a cool event in Moscone Center, big cool event. And
was it in Moscone?
It was in Moscone.
Okay.
And I remember the last Sun Developer Conference, this last Solaris Developer Conference. I don't remember if it was Sun or Solaris. I think it was Solaris Developer Conference. They put on a good show. They had comic relief. It was really cool stuff. And they threw really nice parties in the docks in San Francisco. But I remember the last one. And that last Solaris Developer Conference is what I call Java 1.0.
Okay.
Because the next year there was no Solaris Developer Conference. There was Java 1. Once Java 1 started, there was no longer Solaris Developer Conference.
Okay.
And that happened in 1 year. The thing I remember seeing on stage there was they had the regular stuff and all things, and then Scott McNeely brought out the guy from Netscape onto the stage, and Netscape announced that Java is going to be in the browser. Java was around before that. I'd already played with the alpha.
Was the Anderson? Was it now the guy is the net?
Yeah.
This is the venture capital right now, right? So the guy.
So I don't remember if it was him personally or somebody else from Netscape, but basically that was the big wow moment on stage at the Solaris Developer Conference. Netscape is putting Java in the browser. And that took Java from this little cool thing I played with the alpha of because it was fun to, wait a minute, this thing might be everywhere. And at the time, we thought applets.
Yeah, sure.
This was what it's for. It's for applets, right? But that really is, so I was there seeing that, and I remember doing the, wow, this is big kind of reaction. And that was the last Solaris Developer Conference. Within a year, that thing was replaced with the Java Developer Conference, which was Java 1. And within a year or two, it became clear that Java applets are kind of cool, but Java belongs on the server. And I think that, again, to this day, I'm somewhat of a computer archaeologist. I like to look back and see if I can spot things or date things. I often could look at code that somebody has in a company, and I could tell them when they wrote it because, fashions change. But back then, the web was a thing already. The internet was a thing. Netscape was huge. But I don't know. A lot of people don't remember far enough to remember that the web used to have this thing called CGI bin, where every HTTP request forked a process. And that process basically returned whatever, the way Netscape server worked with that. Right? So every HTTP request was a fork. It ran something. You could make that something anything you want. You could write it as a shell script. You could write it in C. That was pretty much C++. But
Perl.
that was everything,
Perl.
right?
Lots of Perl CGI scripts, back then.
Yeah, those two, and a lot of Bash, a lot of C Shell. Because then it's a fork, do something, return, and all that. And the fundamental reason that worked in
AWS Lambda, right? So this is exactly the same technology.
I joke that Lambda is just CGI being
Yeah, it is. It is a very similar concept, actually. Yeah.
And by the way, serverless containers are to Lambdas what servlet engines were to CGI.
Absolutely. Or I actually, in a few weeks, I'm at a conference where I will explain serverless lambdas with EJBs. There's even more similarities, with pooling, max pool, and throttling and provision concurrency, one-to-one relation, actually. Yeah.
Oh yeah, we keep reinventing the wheel.
Yeah,
I know.
Absolutely.
But and the lessons learned usually repeat themselves. But the thing at the time was, I think that what made Java really take off was that it was the first technology that allowed you to have a web server that didn't have to fork off every HTTP request. And the fundamental reason for that was isolation and stability. So the reason you forked every HTTP request in a fundamental web server, Apache, Netscape, etc., was that thing could crash. Whatever code you have could crash, and you can't crash the server. So forking it off means the forked process crashes, but the server doesn't. It's isolated. With servlets and the JRun stuff that preceded servlets, we basically had the ability to have individual requests run in code that you could load onto a server, but did not risk the stability of the server.
Yeah. By the way, JRun was from Macromedia, I think, right?
Yep.
Yeah, and Chixo. You remember Chixo from Apache?
Yep.
Yeah, also tested that. Yeah.
Yep. So there were all kinds of amalgamations, and then ASP.NET had its own way of doing things, and Apache servers evolved to do better. But we had several years where Java was actually the fastest way to run a web server.
Yes, and this is how I got my projects, because I knew that CGI was slow because it had started, and Java run, so it was significantly faster and also safer. No safety in Europe, huge. And it's okay, sure, Java is safer, faster, and this is why I spent my entire time on the server with that.
Yep, and it let you build things that would survive a single operation and would be useful, like caches.
Yeah.
So with CGI bin, everything was independent and it died at the end of the operation. So there was very little you could reuse. You would, context switching costs, forking costs, all those things were huge. And Java was still interpreted at the time, but interpreted code is much faster than forking every request. So I think that's really where Java on the server took off, and from there it never stopped. Right?
I don't think it was interpreted, right? Because JIT was introduced with JDK 1.17. I think this was early on, so I think it was JITted,
Well, but we had JRun servlet-like things even before the JITs were around.
Okay.
So obviously the interpreted needed to be faster, but even interpreted Java was faster than CGI bin.
Okay. And you spent some time with Java back then already? So you switched to Java completely from C?
Not quite, not entirely. I would say even to this day, not quite.
Okay.
Remember, the JVM is built in C++.
Yeah.
But from a point of view of language, so at the time I'd worked and I played with it as technology, but I worked a lot in the network industry.
Okay.
Firewalls, network switches of various sorts, traffic management things. And those are usually close to the metal, either underneath the kernel or above the kernel or embedded systems. So no Java.
Okay.
We did have, I worked at Checkpoint Software. I worked at Shasta Networks, building some of the first broadband aggregators. So the thing that all the cable, all the DSL, all the things end up in, one machine that has 30,000 homes connected to it.
Wow.
We were not the first to market. We were the second to market with that in the late 90s. And I worked on the actual traffic software for that, and that is all C, C++ kind of stuff. Mostly C with some C++.
Okay.
And here and there, different things. I used Java where I could. So at Checkpoint, we built a GUI for a traffic management system. We built a GUI in Java, right? As a fat Java, not as an applet, but as a fat Java servlet desktop application. So I was one of the first users of Swing.
Okay.
I remember using Swing 0.7 beta.
With ComSun, this was still the wrong packages.
Oh, ComSun. Yeah, exactly. But Swing, I used Swing in a product before Swing was GA.
Me as well. You had to download Swing separately to Java. This was a separate download. And I remember I evaluated Swing and I found out that the text fields, there was like a line missing. There were some lots of visual bugs, so it didn't work correctly. And
And then the first Swing that I used didn't know how to do Windows look and feel.
Yeah.
It had a motif look and feel, open view look and feel, and a metal look and feel, but it didn't have Windows. And then they added Windows just in time for us to have a product, because we were building a GUI for PCs.
Yeah.
So the Windows look and feel was important. But yeah, I used it where I could. I did use it for that. I built utilities and internal programs with it. It was very useful for lots of stuff. At Shasta was really where I made big use of it, because Shasta was bought by Nortel Networks, and we basically ended up with a lot of big telcos deploying lots of machines, and the machines didn't just do DSL IP services. They also allowed you to provision all kinds of cool extra services per customer, like firewalls and VPNs and net nannies and traffic shapers and this cool thing we called a captive portal that we invented at the time, which you would connect in it, unless you made it happy, it didn't connect you to the internet. I don't know if you've been to a hotel or Starbucks lately, but that's something we invented at Shasta Networks.
Okay.
It didn't exist before that. Before that, you actually went to your browser and had to put 10.0.0.1 to connect to your router to tell it, because it didn't just, you open up the router and you try to go to Yahoo, but it goes to where it wants to. We did the hijacking of the HTTP connection logic. Anyway, there's a lot of cool software in the machines, but ISPs would then manage millions of subscribers on hundreds of these machines and needed common ways of provisioning and setting up, profiles and services and other things. And all the software we built to do that was server software running on Sun machines, written in Java to control a lot of network equipment.
Okay.
That was my first actual big server-side Java work. And at the time that we did this, WebLogic wasn't quite ready.
Thank God.
So we ended up building our own app server.
Oh.
This was before JVMs. This was back in the JRun servlet days. But we built our own app server because that's what you did in 1998 and 1999, because you couldn't buy WebLogic yet, right?
Yeah.
So I ended up building the under the hood parts and effectively the app server and a lot of cool client software in Java and stuff like that. And that was really I did a bunch of Java in the late 90s, early 2000s on that.
Which IDE you used back then, you remember?
I used the Borland
JBuilder.
Yeah, JBuilder. It was beautiful.
Yeah.
I still miss it.
Yeah.
And I built some really cool things with it.
And all the software was actually beautiful. So not only visually appealing, even, JBuilder, complete different feel to Semantic Visual Cafe, which was completely different to Visual Age for Java. Then I wanted also to try it, but never managed to, the Code Warrior from Metroworks. So it was also interesting. Then Sun Studio, Studio and Studio Creator. There were two, Studio Workshop and Creator, I think, were two different. So lots of cool stuff back then. And IntelliJ also started, and Eclipse happened later.
It took me a while. IntelliJ was around after that. They weren't around in the like 97.
2003 they were already there, but I had license back then already, but I have no idea how when they started
Yeah.
actually. Yeah.
And these days, I'm an avid IntelliJ
Hmm.
user. I've used them for forever, and I'm one of those people that I get a free. So I'm because I'm a Java champion.
Hmm.
You get a
Hmm.
free IDE or you free stuff. But I've always paid them, and I keep paying them. Like I think they deserve my money.
Yes.
Don't
I'm,
charge that much. They deserve my money. It's an amazing ID.
I'm
So
not
if you
using.
have it for free, this is one of the pieces of software. To me, it's like leaving a tip. It's beautiful software. I want to pay them every year.
Yeah, I'm
Um,
also paying them. I'm not using IntelliJ actually. I'm using Visual Studio Code right now all the time, but still paying at the product subscription. But they are really interesting products. They have the data grip, and I forgot there's a recent software for documentation, also very interesting. So I'm play with it. Yeah, but I,
yep.
I think you should pay for software if you're using
Well,
professional software. No, it is actually, if you earn money, you should pay for the tools, right? What
oh
everyone
yeah.
does, and yeah,
And look, I think, I mean, to me, I miss Borland, the good
yes,
Borland.
yeah,
I use JBuilder, but actually I've used Borland tools way before that. I used Borland
Delphi,
Turbo Pascal 1.0. This
okay,
is before they had Turbo C.
hmm,
And like this back when you could actually, you had the code for the text editor, so you could hack on the text editor in the thing. So I've used, this was from mid 80s, early 80s.
What I never understood, and I thought they will fail already if I heard about that, if they started to migrate to Eclipse. I say, okay, this won't fly because you can just Bolland was different to Eclipse, but if you just become an Eclipse plugin, I mean, this is different story,
Yeah. Although, look, I went from Borland to IntelliJ, and IntelliJ was great. I used it,
Hmm.
and I tried the other things. I mean, look, I don't have a language religion. Also don't have an IDE religion. If there's a project that people use a tool, I'll use the tool. I don't
Hmm.
bring my own. I don't insist on using Emacs or VI.
Yeah.
My fingers are probably, they remember Vim better than Emacs, but whatever tool people use in a project. Um, and this the Eclipse folks might not like me saying this, but a, a few years ago, several years ago, I tried to use Eclipse in a project for real, and that was my first attempt to use it fully. And at that point, I started understanding how good IntelliJ really is.
Yeah.
Until you start using another one, it wasn't there. So I don't have a lot of experience with Visual Code. I've used it obviously, but not. I can't claim to have tried a big thing for a long time in it. Um, but I, when I tried Eclipse for a while, and I thought it was very mature at the time and should be same, I found so many things that I thought, oh, how? I mean, I just took it for granted in IntelliJ. Simple things like, you know, if I edit the code and things break, things go red. Um, you
Yeah.
know, and if you compile, it'll compile the right things and
Hmm.
that kind of stuff. I always took it for granted. It'll just do all the right things. I can rely on its indications. And with Eclipse, I learned the hard way that no, these are kind of advisory hints, but sometimes there's an error it won't tell you about. Sometimes it'll tell you there's an error and there isn't. Um,
Yeah. So IntelliJ is the best, and Visual Studio Code is not as good for Java. But I use Visual Studio Code for different reasons. What I can do, I can open simultaneously 5 folders with Visual Studio Code, different projects, and it immediately recognizes the Maven. And then I open the terminal, work with Maven natively, and the editor is good enough. So I'm very fast. I don't need sophisticated, refactoring strategies. And if I would um, um, work longer on a project, I will pick IntelliJ. But
yeah,
I'm working on many
heavyweight.
projects
That's the one
simultaneously.
thing about it. It's
Then I
heavy.
have, yeah, and then I got to know
So
Copilot first. It was not available in IntelliJ. I know I work with JavaScript and web components, and all the web front end developers are using Visual Studio Code. So that's the reason. And the future seems to be, from IntelliJ perspective, is Fleet, and Fleet looks almost identical. to Visual Studio Code, right? So this is
Yeah, no, I see the similarities in there, but look, I think the lightweight part, I just have a Java file. I want to open it. I don't want a project.
yeah.
Um, that, that that's the one thing that still bothers me. It just wants you.
Yeah.
Wait. Before you do anything with the code, let's talk about the setup.
Yeah, and this is what I don't like at all, right? So if you start with the Maven model and ask me, and this is why I also preferred NetBeans, right? I use NetBeans a lot. I opened the folder and it worked, and then I just deployed the project and moved on. So this was my way of working. This is why I also prefer Visual Studio Code. Okay, so you spent lots of time with Java back then with Ball and JBuilder. So you keep doing Java for the companies, or what happened then?
Well, okay, so you probably remember that in 2001 the world
Yeah.
collapsed for many reasons. One of them was the internet part. 9/11 was another part. But really, from a technology point of view, I was actually kind of lucky. I'd actually left Nortel and decided to take some time off and fly around the country. I had a small plane and stuff for a few months, right when all this was going on. But when I got back, I started looking at things and brainstorming ideas for stuff. And this was at a time when nobody was funding anything. But we did look at a bunch of ideas for things. And one of the things that kept coming back was I had this experience from Nortel and Shasta building both big network equipment that had hundreds of CPUs in it and independent cores and all that. And I did parallel scale for machinery that needed it. And at the same time, we built very large Java software on machines that had 2 or 4 CPUs. And clustering wasn't a super powerful thing back then. You needed a lot of machines for the stuff we were doing because it was scale. And I was looking at how people run network equipment and how people run Java software or server software, because all applications were being built now in app servers, and they didn't look the same. The hardware was not the same. And we somehow coalesced into an idea. And remember, Azul's history. I'm going to get up and just close the door here for a second because my dog is barking a lot. So, on the one hand, I worked on machines with hundreds of CPU cores doing very productive network packet processing work. On the other hand, I'm working on the software that's supposed to be even more scalable than a machine, and it's using servers with 2 and 4 CPUs, gigabyte, 2 gigabyte heap maybe kind of things. And if you wanted a lot, you got a lot of machines. This was early 2000s. We came up with the notion that maybe we could abstract and consolidate hardware in server data centers and by building hardware that is good at doing that, the Java kind of workloads. We were looking at it, by the way, as Java or .NET because it wasn't clear which one of those is winning, but they look a lot the same. And the idea was, okay, let's let computers do what computers do, operating systems do what they do, but in the same way that as technology becomes prevalent, you build good scalable things that do it rather than a lot of little pieces. Maybe we could do that for compute power for stuff, CPU and memory. Now, the analogies we were using at the time were things like file servers, NetApps, or EMCs for disks, where disks used to be this thing that was in a computer on the end of a SCSI cable. Then we put it at the end of a fiber channel cable that emulated a SCSI cable. Like you use the same SCSI protocol. Then we put it at the other end of a network connection that emulated iSCSI over it. That happened later too. But basically, you end up abstracting it over a network. You concentrate the capacity in large machines that are good and efficient at doing it, and you mount that capacity from a lot of machines. So computers mount their disks from the outside, don't bring their disks on the inside in big data centers in general at the time. Similarly, routers and switches. Routing used to be something a Sun server did. Packets used to go through the servers to other servers. The network wasn't next to you, it was through you. And then Cisco and Bay Networks and others started making machines that were good at routing, and computers became edge points rather than the network itself.
Mhm.
And again, this was you mount the network rather than you are the network.
Mhm.
But throughout, every time you do this, there are protocols that you enable this. Ethernet is a protocol, Fiber Channel is a protocol, SCSI, NFS,
Mhm.
CIFS. These are protocols. TCP, IP, and IP, and those. Now you keep the protocol the same. You change the hardware implementation. You consolidate. You build big things. But the very important thing is you don't change the software. The software doesn't even know this happened.
Mhm.
Like from the software perspective, it's the same. Remember what I said about the Stratus fault-tolerant
Yeah.
computer? It's the same. You run the same software, just better hardware, better layout. So we're looking at it as, okay, how does Java get deployed? You want to build a good Java business application? Go buy 20 Sun servers, put them in a rack, and run across them the same thing, right?
Mhm.
And each one of them has 4 CPUs in it. Well, what if we could make a mountable amount of compute that a Sun server could mount? And it would run, the software wouldn't even know any changes happened, but it wouldn't actually be the Sun CPU and memory. It would be something else.
Mhm.
And that's what Azul started off building in our Vega machines. We built what we called compute appliances.
We have to cover this next time, but what I have to know, why the name Azul?
Um, Azul was actually a name we picked with, the classic. We tried a lot of names. We thought about it for a month or two, and we picked it. For the first year of our life, our name was Chestnut Systems.
Okay.
And we picked Chestnut Systems because we needed to pick a name, and we were standing on the corner of Santa Cruz Avenue and Chestnut Street, and Santa Cruz was already taken.
Okay.
So that we knew we would change the name anyway, so we picked Chestnut Systems.
Almost like oak, right? So chestnut, oak.
Yeah, a little bit that too.
Yeah.
That helped a little too. But yeah, it was the name was more. It starts with an A. People seem to remember it.
Mhm.
They have good connotations. It's the color blue in at least 2 languages.
Yeah.
Okay, good things.
What I'm thinking, if you explain how it worked or what was the idea back then, it was almost like what clouds are doing right now, right? What you described was the EC2 machine, actually. What AWS is doing with the Nitro enclosure, and everything is separated. The network happens outside. If you have firewall rules, they don't happen on the machine; they happen outside. So it is very similar, and you did it when 20 years ago, 24 years ago, right? Before
Yeah,
AWS.
we weren't the first to virtualize something either.
Mhm.
But I think we used Java as a
Mhm.
virtualization mounting point.
Mhm.
So you would run a JVM on a regular operating system, but what you ran wasn't an actual JVM. It was a little shim
Mhm.
that would go find an appliance, instantiate an actual JVM in it, and then just forward traffic back and forth to it in a way that made the rest of the world to think this is a really powerful Sun machine. And not only does it have a huge disk, it has a huge amount of CPU and memory for this Java thing it's running because it's really fast and big.
Mhm.
And for the software to think it's living there,
Mhm.
like everything that you would run in the JVM on our appliance would observe the world through the thing that mounted it. So it would see the current working directory in the Solaris thing when it opens files.
Mhm.
Its network would go through it. So neither the Java software, nor the world around it even knew that the appliances existed.
Mhm.
And that allowed it to virtualize Java. Now, I'd call it virtualized Java today. We didn't use those terms back
But how
then.
it worked for me, just I would like to understand it. So you had a software which you have to install on the Sun machine, and this was more like JVM proxy, to my understanding, right?
Yeah.
The software run or the JVM proxy, which forwarded efficiently what the traffic to your Vega machine, and the entire compute happened on the Vega machine, right?
Yes.
So
So think about it. The proxy also came with the binary for the Vega machine to run. So it would start up talk to a machine and shove the actual JVM code in there. If it wasn't already if it was cached, it wouldn't need to send the bits. And then everything you can think of that's Java was running there. The only traffic between that JVM backend and the proxy were network buffers, file buffers, and JNI calls.
Mm-hmm.
Everything else was done locally inside the appliance because those three things are the only interactions Java has with the world outside of a JVM.
Ah, okay. This is the
Right.
so Vega was about compute and the Sun was about I/O, or otherwise other way
Yeah,
around.
it would be. We had JVM proxies for Solaris, for AIX, for HPUX, for Windows, for
Mm-hmm.
Linux. We had a ZOS proxy.
Mm-hmm.
So you could mount an appliance from ZOS and run Java on it.
Mm-hmm.
Sorry, a Z-Linux proxy,
Mm-hmm.
not a ZOS. But you could. It was the same hardware. You can mount it from anything, just like a disk, just like a router. And the JVM was this. We would just have a proxy for each operating system, but the JVM code was, Java 1.4.2, for that thing. The the way to think about it is that, like, the breakthrough for us was, you think of it as, okay, I have the compute here, but the computer there. I'll have a lot of round trips
Mm-hmm.
back and forth.
Yeah.
But that's the thing; they're not round trips. They're just a bump in the wire.
Mm-hmm.
You only go there when you're already going to somewhere else. You're going to send a network packet across a millisecond of stuff. The extra hop to your proxy is nothing. You're going to talk to a rotating piece of Rust disk
Mm-hmm.
that's 8 milliseconds away when you need a thing. Going through a network bump to get there doesn't really change much.
Okay.
It adds a tiny bit of latency. Bandwidth-wise, there was no problem.
Okay.
And nothing you would do in Java code would ever cross the line, right?
Mm-hmm.
It's only J and I calls that would. And even those, we had all kinds of cool ways to make them efficient. So, for example, all the J and I code that did not interact with the operating system would run in the back,
Mm-hmm.
right? So, all the JVM local J and I code, that didn't cross the wire, right? So in reality, we would run WebLogic and WebSphere and JBoss later and stuff like that, and they just run very happily on our stuff and run better because we had hundreds of CPUs. A computer appliance had up to 800 and some CPUs and 3/4 of a terabyte of memory, and it could host 300 of these mounted JVMs from as many machines as you want.
Mm-hmm.
So, and there were farms of these computer appliances. So the virtualization went as far as, we did a lot of stuff that today you end up doing in orchestrators. Like, okay, if I have two different JVMs launched for two different machines, and it's the same WebLogic cluster, I don't want both of them to mount the same physical appliance because that creates a point of failure. So you have anti-affinity rules and then affinity rules for things that you want together. You see that today map a lot with, how Kubernetes has to decide to place pods for enough redundancy on hardware. And we have a lot of things we built back then because of that virtualization. But fundamentally, we virtualized with Java being a mount point. The thing that really did it better than us was VMware,
Mm-hmm.
and later other hypervisors that virtualized at the operating system level.
Mm-hmm.
So we virtualized and used Java as a mount point in a time where x86 was still a toy and most servers were not x86,
Mm-hmm.
and Linux was just coming along. VMware virtualized x86.
I just how I would install. So I would install, the Azul software on Sun. Then I will launch Java on Sun, and it will actually run on Vega. So this is the trick.
And you would install just like you install any JDK, right? Like you'd install JDK, you wouldn't have any other software.
Yeah.
When you run Java, you're just starting the proxy. It discovers our network of appliances.
Mm-hmm.
There's a Java, something we call the CPM, a compute pool manager, written in Java, running on the appliances that would figure out where to send you, which appliance should actually serve you,
Mm-hmm.
and then that's a policy decision, right? You started up, where should we put you?
Mm-hmm.
And then we would point you to an appliance that had enough capacity and room for the policy to put you there. And you would shove the real JVM in there and start it up, and all this would happen in sub-second times.
And the redirection happened in the class libraries of Java or deeper? So you
deeper. It was the JVM itself.
Okay.
So think about it as, at the JVM layer, we implemented a lot of the things that an operating system does for network protocols and file buffers.
Oh, then I
So
understand. Then it is like the Java didn't knew about that, but the JVM, also I mean Java means the class libraries and the application had nothing to do with it, and you consider the JVM as an operating system as like right, and you say okay, and if there is a network call or I/O operation, so it has to be translated to the operating system call, and you just called the Vega system instead, right?
exactly, it goes down to the Vega level and proxies across, and all those they're done in the context of the proxy. So we would have a pipe that multiplexes lots of traffic going between the proxy and the JVM. On that, we'd run mostly TCP/IP and file buffer traffic.
Mm-hmm.
Um,
But what do you
and
gain out of that? Because the compute happened on the Sun machine, right? So if you need lots of compute, I mean,
now the compute all happened on an appliance. All the Java
then
CPU and
threads
memory.
as well. So the threads were
Oh
started. Yeah. Okay.
yeah, there were
So
no threads on
okay,
the Sun machine at all. Right?
because threads was system call as well. So this was the trick. So whatever.
Yeah,
Yeah. Of course. Yeah. Of,
yeah.
of course. So you not only network and I/O. So you whatever all syscalls to operating system you could intercept and decide that they are running actually on the Vega system.
Yeah, exactly. On the
Yeah.
Vega, I had a full kernel to do all that, and it was a much more scalable kernel. We had a scheduler that could do 800-way SMP scheduling back in the early 2000s or mid 2000s. So
But this was
it
smart what you did because I think I just thought okay if you fiddle around with Java I would have to invent some remoting protocol would never fly. But this was interesting design.
yeah, it was all under the hood, making Java believe nothing happened.
Yeah.
Um, and it worked. It worked great. We had to give you an example of how far we went with this virtualization optimization. Because the machines were big, it would be very common to have a lot of proxies use the same hardware.
Mm-hmm.
And if you looked at the layouts of clusters, for example, a WebLogic cluster would have a lot of cross chatter
Mm-hmm.
within the cluster.
Yeah.
Or you would have things like a cache server and a lot of clients that talk to the cache,
Mm-hmm.
or a data server and a lot of clients of the data. Different JVMs talking to each other across a network between different machines in the normal world. But when those machines would mount all that stuff from our appliances, you could set up the affinity so that one copy of a data server and a bunch of clients would sit together, and the other copy of the data center that's redundant would sit there, and those clients would be there. And then you would have, say, a client JVM talking to a data server, two different JVMs, going through the network of one machine, two switches, back to another machine, talking back and forth. But both of these are in one appliance. That
Mm-hmm.
would be common.
Mm-hmm.
So we would identify when two JVM talk to each other. And we would let the network connection start and run and be successful, because we have to let the operating systems and the firewalls do their job. Maybe they don't want this to happen.
Yeah.
But once we established one, we would actually have a broker that would match two sides of a TCP connection and recognize this one's talking to that one, it's on the same machine. And then we would start running the traffic in memory between the two processes without doing any network traffic at all. So you would have two Sun machines talking to each other, client and server, big data, not big data, but a lot of data stuff. And in reality, those two Java things were cutting through in-memory communications on a common big appliance with throughput that wasn't even approachable over a network.
But VMware could never compete with their design. If you install Java on VMware, it was a complete different design. I mean, this is such optimization would be not possible
for Java. What they did though is, if you look at the core business problem we were looking at, you have a lot of machines. Each one is running one application.
Yeah.
Let's have fewer of those machines mounting more powerful compute power,
mm-hmm.
so that you only need two or three of any machines for any one application.
Mm-hmm.
VMware went and virtualized x86, let you put a lot of applications in one x86 at a time where x86 was taking off and growing. And they could do this for any software that ran on x86, not just Java.
Yeah, but I was more interested in Java. And by the way, I really, I think I would really like to have, the Vega machine. So for me, it's like this is really a cool technology back then. But this was hard to justify because I know my my server was fast enough, but I was at Java 1 and I look at the machines and they also look beautiful, the Vegas. So it was really, it's like the Java host for me. This was the cloud. Actually, so this is how cloud should work back then, right?
Yeah, this if it weren't for hypervisors, this is what cloud would have been.
Yeah,
For
absolutely.
.NET and for Java.
Yeah.
But I have to admit, somebody else solved the core business problem better. They virtualized at a different layer.
But I would
compatibility, software didn't have to change, but they found a way to. What we have today in cloud is really powered by the fact that hypervisors became a thing.
But I think we covered now. This was a important step, to understand Zinc and everything would happen afterwards. So I would say, in the next meeting, I would like to invite you back to AHEX FM and just talk, about modern Azul. What are you doing with Java, and really about the features you can, whatever you did. This is just an interesting story, And
I think a cool turning point we could take onto the next session is, okay, this is the background of what we built and why we built it, but the reason we built it went away. It was solved better in a different way. Along the way, we built some really cool technology to run Java on monster machines, because we were the only ones thinking of how to do Java on 100 gigabyte, 100 CPU thing at a time where other people didn't have that hardware yet. So we had to solve things ahead of other people. And we could talk maybe in the next session on what that looks like.
Yeah.
What did we do that was special? What issues did we tackle before other people did? And how does that lead to the Zing we have today? And actually, not just to Zing. I think a lot of what OpenJK has evolved to doing today came from things we pioneered on Vega in the 2000s.
Sure. But I'm also very interested to know about the chip design inside the Vega, what it was, and about the hardware. So we have at least, covered this briefly before we start with Java. I'm also interested on it.
We definitely do that.
Yeah. Thank you. Where people can find you and where people can find Azul, maybe your products, and
So Azul today doesn't make any hardware. This is a cool,
it's a
nostalgic look back at history.
But you still, I guess you have a Vega at home yet, right?
I have one in the garage.
Yeah.
I just, as you were talking, I looked up on eBay. You can buy a Vega 3 appliance for $10,000. It has 864 CPUs and 384 gigabytes of RAM.
Still impressive to this day, right? This is interesting.
Yep, and this is something we designed in 2006. But nobody's running Vega machines anymore. I actually had to go to our last customer and give them the bad news that we will no longer support the hardware. I think it was probably 8 or 9 years ago.
Okay.
Maybe less. No, but maybe 7 years ago. They lived for a long time. They were a very impressive piece of hardware, and they were very rock solid. One of my favorite examples there was we had something we called the 500-day bug. It's a bug you run into after an appliance is run for 500 days without stopping. And we ran into it multiple times, and back to back at the same customer. So think about it. You only see this if you've been up for 500 days. So that's how solid the machines were. But there's a lot we could chat about the hardware.
Yeah, this is absolutely so.
But Azul today makes pure software. We make JVMs, make JDKs. We make regular good OpenJK for people to use because they want support and don't want to pay Oracle and want good, stable, secure builds. Or we make the fastest, best JVM on Earth in Zing, which inherits a lot of the Vega technology, but in software. It's fastest, it's the cheapest to run on, meaning you spend the least amount of money on cloud dollars to run your infrastructure. It doesn't pause, it starts up and warms up smoothly. It's got a lot of cool stuff to it, but it's software. We don't do hardware anymore. And we basically do JDKs, JVMs, and things relate to them. We've expanded into cool things that talk to JVMs and either make the JVMs better or give you interesting insight and analytics that only JVMs could give you. And that's other products that we have. But
and of course, you forgot to mention Crack, which you invented, right? And Crack, and also cool product what I like is inventory, where you can run, and you see for migration projects which pieces are used and which were not used. So this is also interesting technology. But next time, otherwise we spend the entire night, talking about Java. So this is a really problematic topic. It's too interesting for me. So where people can find you, maybe you are on Twitter, Blue Sky as well.
I'm at Gil Tene
Mhm.
on Twitter and Instagram as well. I have, I'm on GitHub. It's again Gil Tene, and
Yes, you're still hacking code.
yeah. I've accidentally written some things a lot of people use. So I found out the hard way when Java 9 came out that I'm the reason Spring Boot doesn't run on it.
Okay.
Because they use my libraries.
Mhm.
So I had to make my library work on Java 9 so the rest of
Okay.
the world won't get stuck. And recently found out that I have code running on the Morris helicopter.
Oh,
Um, or was running until it crashed a month ago.
yeah. But
But
it
it
was
ran.
not your fault, right? Not that
That thing actually lived a lot longer than
Yeah.
it's supposed to. But I found after the fact that they used my code, which
Pretty
is great.
cool. Yeah.
So yeah, I do still do a bunch of weekend coding, is the way I'd call it.
That's the best. Never give up. I think this is even if you're a manager, you should still do some coding for fun.
And I even I have a talk I gave at a couple places. The title of which is "Where Do Libraries Come From?"
Mhm.
Or the actual nickname I have it is "Mommy, where do libraries come from?"
Okay.
it's,
Cool.
it's a weird thing about how you accidentally write code other people use and then get stuck maintaining open source for a long, long time.